So let's start with some basic facts about fractions. First, fractions are made of numerators, denominators, and fraction bars, where the numerator is the number that's above the bar, the denominator is the number below the bar, and then the bar separates the two numbers. Second, fractions can be used to indicate division. So for example, 8 over 4 represents the division fact 8 divided by 4. So thus 8 divided by 4 is equal to 2. 8 would be the numerator, but it's also considered to be the dividend. 4 is the denominator, and also called the divisor. And then the quotient is 2. Third, fractions can be used to indicate equal parts of a whole. In our everyday lives, we often deal with parts of a whole. For example, we talk about parts of an hour, parts of an inch, and parts of a pound. And the other examples include half an hour, 3/8 of an inch of rain, a quarter pound hamburger, and so on. In the figure below, you see here, what fraction part of the figure is shaded? Well, we need to figure out how many pieces there are. So there's 1, 2, 3, 4, 5, 6, 7 pieces. And 3 of them are shaded. So 3/7 are shaded. As for the part that's not shaded, well, that would be the 1, 2, 3, the other 4. So 3/7 is shaded, 4/7 is not. Alright, the next basic fact is denominators of fractions cannot be 0. So 7 over 0, 23 over 0, 0 over 0, those are meaningless expressions. And we already talked, you cannot divide by 0. So if you think about like repeated subtraction, like 7 minus 0 minus 0 minus 0 minus 0, you're never going to get to 0. However, 0 over 7 is always going to equal to 0. And basically 0 over any non-zero number is equal to 0. So it's fine to have the 0 in the numerator, not so much in the denominator. Fractions can be negative. There are times when a negative fraction is needed to describe quantity. For example, if an earthquake causes a road to sink 1/2 inch, the amount of movement can be written as negative 1/2 inch. The negative sign can be put in the numerator, in the denominator, or in front of the fraction. However, the number of negative signs remains the same. So negative 1 over 2, 1 over negative 2, or the negative of 1/2, those all mean the same thing. Likewise, negative 15 over 8, 15 over negative 8, negative the 15 over 8. So it doesn't. If you have a negative fraction, it doesn't matter where you put the negative. Fractions can be proper or improper. So if a numerator of a fraction is less than the denominator, the fraction is called a proper fraction. So a proper fraction is always less than 1. Examples of proper fractions include 1/4, 2/3, and 98 over 99. If the numerator is larger than the denominator, those are called improper fractions. So improper fractions are always greater than or equal to 1. So that'd be like 7/2, 98 over 97, 16 over 16, 5 over 1. Improper fractions can be written as mixed numbers. So if you look at this circle, each circle is divided into 6 parts. 13 of these parts are shaded, so you could consider this fraction to be 13 over 6. Back up. But I can also write this as 2 whole fractions and 1/6 of a third. So 13 over 6 is the same thing as 2 and 1/6. A physical or pictorial representation of a fraction must clearly answer the following questions. When you draw a picture to represent fractions, you need to make sure what is the unit. How many equal pieces has the unit been subdivided into? That would be the denominator. So if a circle is your unit and you cut it into 8 pieces, then the denominator is going to be 8. And then how many of these pieces are under consideration. And those are typically the ones that are shaded. All right. There's a Geogebra activity called guess diffraction. And the idea there, here it is right here, is you have this picture and you're trying to guess diffraction. And it can be a bit tricky, but makes for good practice. This case here, I would say 1, 2, 3, 4, 5, maybe 1, 6. See how I do. And whoa, got it. Some of them can be a little bit more tricky than that, but anyway, it's fun to play around with.